I'm Evan, and I'm here for reviews from the 8. I've been talking about building your apps with Java 8 on Android. So I'm an Android software engineer. I build your apps in Durham, and today hopefully I can convince you all to upgrade to Java 8 and building Android apps, which may or may not happen realistically, but we'll see how it goes. Do we have any Java developers here and who have used Java 8 before? And so this is like actually not that brand new. Java 8 really came out over 2 years ago. But as we'll see, Java 8 on Android is kind of like a brand new thing, and it's so new that it'll be a couple more years before you can really use it. But we'll just proceed as if you can use it today. So I'm glad everybody's here. So this is kind of a code lab, but I'm gonna spend the first kind of 10 to 15 minutes going over why Java 8 on Android matters now. So I'll be kind of going through history on how Java and Android and how they relate to each other as far as app development is concerned. Then hopefully we can all get set up with a development environment. And then do some live coding. Of course, that's good. That's the fun part. And then wrap it up with some links and resources and then some caveats. So I do want to stop here and say that in order to successfully deploy an app to an Android device running Java 8, you need to have several things installed and download several hundred megabytes of tools. So now we're going to see if the Wi-Fi will hold up. But you need kind of 4 different things. You need Android Studio 2.1, the Android N Preview SDK, and if you really want to see your app in action, you need a device emulator running Android N. All that is available at d.android.com/SDK. And then finally, you need a Java 8 SDK to be able to compile your app. So it's about 10 minutes before you start live coding, so you can attempt to download everything you need. Hopefully it all works and doesn't crash the live stream. So while that happens, I'm just gonna fill the next 10 minutes with some history. And hopefully everybody can download to the heart's content. So a little bit of history. So when Android was released, it was released kind of around the Apache Harmony base implementation of the Java APIs, and that supported JDK 6. So that was all good. Google added support for Java 7 in 2013. Important to note is Apache Harmony was retired. So active development stopped on that right around the time where it finally supported Java 6. So Google worked and added Java 7, of course. And then things just fell behind. Java 8 came out 2.5 years ago, and Android developers kind of used some Java 8 features through other libraries, but not really. Android N. And so we're getting JDK 8 support finally in 2016. Kind of the implication here, though, is Google swapped the underlying API implementation from the existing Apache Harmony to OpenJDK. So now we essentially support all the Java specs supported by OpenJDK. It's not the entire Java 8 API set, but we are kind of just blessed to have streams and retro and lambdas and kind of more functional interfaces and such on OpenJDK. Hopefully, this means also that Google will be more proactive about supporting future versions of Java. So hopefully, next year, I'll be talking about building your apps with Java 9, which comes out. Any questions? Nope. All right. So in the meantime, does this mean we've been coding like animals? So essentially, not using any lambdas, using crazy for loops to do filtering, et cetera, et cetera. Kind of not really, because the developer community is pretty awesome. And so you have libraries and APIs available that are all open source, like Retro Lambda, RxJava, Stream Support API, that kind of backport a lot of the important Java 8 features to earlier versions of Java. So Java 8 support in Android not really being there has not really been a problem. at all, as a matter of fact. But it is nice to see Google continuing to move their platform forward with, of course, new APIs, new sensors, new hardware, but also just new language features, which makes the developer quality of life a lot better. So this is what you need to get up and running. Everybody has gotten. Probably not very. Halfway, okay. So I'll pause here and ask if there are any questions so far. Yeah.
I was just wondering if you code with the current code and then try to upgrade to Java 8. I understand it would probably still work, but if you wanted to move everything to Java 8, I imagine it would take a lot of refactoring or?
Not a lot. So moving to Java 8 just means you would end up using certain language features to make maybe some part of your code more either readable or push to like a functional type of thing. So
but if I wanted to stop using the old stuff, I'd have to.
Oh yeah, definitely.
But out of the box, my old code just builds, right?
It does just build, yeah. So your existing Android code 6 will work when compiling on Java 8.
Can you mix it?
Yes, you can. Yeah.
Or if you started on one, you can then have half of it start to use Java 8, or
yes. Okay. Yeah. So our live coding example is actually going to be an app called Mascots that I put together. Super simple app. It just shows a list of mascots from area schools. So mascots from UNC, North Carolina Central, Duke, and NC State. I'll leave this up here so you can actually clone the repo too, and we can work on it together. We're going to take a couple different sections of this app and move it to some Java 8 API or language feature. And I can show you what it looks like real quickly. So it's this really basic app. Has one screen. And yep. And of course, it doesn't show up on here. Oh, wow. Okay. Let me reboot this. Cool. So super simple app that shows 4 mascots. You can press them. They say whatever the school's big thing is at football games or whatever. So Mr. Wolf is Go Pack. UNC's Go Hills. I kind of guessed on Eagle and said Eagle Pride. And then I have no idea what they say at Duke games. So I'm just going to short it out. So we're going to convert a lot of this. Well, not a lot, but some portions of this to Java 8. So are we all at a good point to start setting things up? Nice. Actually, let's go. Sweet. Okay. So setting everything up entails, first step is once you have all the tools in place, like Android Studio, the Android in Preview SDK, and a device, hopefully. It's just a matter of creating your first Android project, or in this case, we'll be modifying the mascots app and changing these attributes. And so very first thing we want to do is change the SDK we're going to compile against, and that should be Android-N. We're going to use the latest build tools, which as of like yesterday was 24.0.0 space RC3. So min SDK and target SDK version, we want to set those to N, or if you get some super obscure Jack error message, make it 24. And this essentially will limit us to only running this app on Android N devices, which is why you need an emulator or a device running Android N. And I'll go over that. It's more detailed toward the end. Next, we're going to enable a new compiler for Android called Jack. And Jack is required to use Java 8 on Android. And because you must use Jack, there are tons of caveats there as well. And I'll explain those as well. And then finally, we have to tell the IDE that our source and target compatibility will be Java 1.8 or Java 8. And so I'm going to actually step forward and talk about Jack a little bit. Well, I'll give you guys time to download some more stuff. I'll flash this slide up again in a little bit. So if you didn't get a chance to change your settings, you can do that in a few minutes. But so Jack is a new compiler or a new build toolchain for Android that will turn your Java source code into DEX bytecode. So Jack is an acronym, stands for Java Android Compiler Kit. Exactly this. Compiles Java source code into DEX bytecode, but also does other things like removes unused classes, obfuscates your code, does repackaging and multidexing. Multidexing is kind of an advanced Android topic, which you would know about if you've kind of hit that DEX issue before. And it's required to use Java 8. Jack is super experimental, so it's still in preview. So there are things that if you use an existing app that's in production, for example, and you have maybe used some third-party libraries, they use annotations, and you enable Jack, you'll break things everywhere. So just keep that in mind, and I'll go over that as we proceed in this demo. So I'm going to flash the previous slide back up here because we're about to jump into some code. Cool. All right. Okay. So now I have my mascots project open in Android Studio. I have my files here, and first thing I want to do is open up my app build grader file. And as we see, this app supports 19, I think that's Lollipop or KitKat, all the way through Marshmallow, which is no longer going to be a thing for us. So our compile SDK version here, we want to make it Android N. And as instructed, we want to change the build tools to 2400 RC3. Nope. Oh, yeah, I'm totally sorry. I guess it is bigger for me. There we go. Way better. Is that better? Cool. All right. So Min SDK, Max SDK version could be 24 or could be N. Actually, when I was running through this yesterday, I set it to N, and I ran into tons of Jack compiler issues, so I'm not sure what's going on there. Next, we need to enable Jack. So that is Jack options, because this is, I think this is Groovy. You enable Jack like this. And then finally, the last step is going to be copy and paste this. Cut compile options. There we go. This could be, you can use 1.8 here, or you can use enum for it. Copy and paste this, and this point, our app should be ready to use. We should be ready to stick Java 8 code into our app. This is going to bark at us because, so these are support libraries down here. We actually should upgrade these as well to use the latest version, which are an API level higher than 23. I think the latest ones are 24.00 Alpha 2. Now, assuming everything goes well, we can hit sync now and build, and hopefully we should hit no errors, which I think that is the case. Cancel. Okay. So now our app is ready for Java 8. So we can start off with something super easy and just look at the code. So the big thing in the improving by Android Studio is actually when you enable either Java 1.7 or 1.8 support, it'll actually bark at you and tell you that, hey, you're using this anonymous class here, you can make it a Lambda. So as you can see, we have a ton of these things here, and they're not hard to look at, but they kind of make these really just end up doing one thing. This one thing has 5 lines of code, but it just prints a toast message out. And so we can put a Lambda here. Now you can let Android Studio do this for you, which is a great tool, replace with Lambda, and it's way more readable. Essentially, this is the functional interface that, because the on-click listener is a interface that has one method, it can turn that into a functional interface and use it in a Lambda like this in this way. You can even take this a step further and put a method reference here. So if I wrote a function called private, let's do show toast. I'm basically going to do the same thing. I can replace all this with a method reference. And you can do several things. So since the method I want to call is a member of this class, I can just do this show toasts, and the code that you saw, that 5-liner, which did one thing, is now a method reference that does this one thing, and it's way more readable. So that's a functional interface and method references. So you can do the same thing here. This is an async task, and I'll go over that later, but this is doing a little bit more. Since this has two methods, and this is not an interface, this is an abstract class, it's going to be harder to make this look as good as this on-click listener here. But the least I can do is make this a Lambda. So right-click, or you can do, let's see. And it's a tad bit more concise. And we can, oops. We're going to run this. And ideally, the app does not break. And so I modified the on-click listeners to use lambdas, and one uses a method reference. So when I click on a mascot, it should still do the same thing. If I long click on it, it should print a goofy toast on it. So let's make this a little bigger. And if I press Ramsey, it still says Go Hills. If I long press on it, I am Ramsey. So Java 8 works well here. So next Java 8 feature, I'm going to go through our repeatable annotations. So if we go to, yes.
You used it enough to know if there's any performance difference using lambdas, in particular, if we specialize collection classes or iterators.
Yeah.
We're now, should be the workable site. You don't have to write the loop, it's the collection class where itself has an iterator, and you just pass in the lambda, the map over. Do we think there's performance wins, or is it really just sort of readability of the source code?
So I was reading, so I don't know the answer totally, but there is actually a when the app is compiled, the way you specify your reference here could cause, so if, for example, if this wasn't a click listener, this was a callback of some sort, and this was in a for loop, where an anonymous class is generated that holds on to a reference in a outer class, it'll create objects for that, it'll create one class every time that loop runs, which puts pressure on the garbage collector, which causes that to run earlier, which may interrupt your app for to clean up the unused classes. That's probably the most I know about that. So it's, to me, it's mostly about readability and your code being concise, but I would imagine there are implications on performance depending on how you reference, how you build your lambdas, and whether you reference variables that are outside the scope of that lambda, for example. And so here, for example, I am referencing a string and a view that's in this outer class called mascot holder. So if this were in a loop, there would be one anonymous class generated for every iteration of that loop. So kind of you have to be mindful of the compiler and what it's doing versus the garbage collector there as well.
Yeah. Question. So in the case of that lambda, the second one you used with the on click listener, can you still use the parameter that would have been passed into the equivalent function? Because like on click listener would have taken a view, but you're not like declaring anywhere. Or I guess is the view before the arrow, that's the statement of like the parameter name that.
Yes.
Yep,
it is.
So if you have multiple parameters, it's just like view, comma, blank, arrow?
Yes, I can actually show you. So I'm going to quickly put together interface tests. We call it test lambda. Lambda, and we're going to do void global and I int j. All right, so now if I do test lambda equals new, so here you can see we have, so it tells us that we can make this lambda, so I can do that. And it replaces our multiple parameter with parentheses I, comma j. So you can't use more than one variable with functional interface. You can use up to however many you want. So we can actually leave that there because that's hurting nobody. All right, so now we're going to move on to static and, or actually let's move on to the primitive annotations. So I have a mascot interface, which each of these mascots implements. And so we're going to jump to, since we're at UNC, we're going to jump to Mr. Wolf. So I have repeatable annotation. So in Java 7 and below, in order to kind of decorate this class with more than one of the same annotation, you had to do this kind of very verbose annotation style seen here. So essentially what this says is Mr. Wolf has an annotation called CNAP places, which is an array of CNAP places. So this annotation is specified as such here. So as you can see, this annotation is just holds an array of CNAP place objects. And this annotation just has a string called name. And so Mr. Wolf is annotated to be seen at basketball, football, and baseball games. All right, so that's part one. So this is kind of, so this is not that bad. However, using reflection to read those annotations ends up with a kind of for loops. And so this for loop here, that for loop is going to iterate over all the annotations on this class. And this annotation is a CNAP places. I'm going to loop over all the values in the CNAP places annotation, if this makes sense. So essentially what I want to do is take all the annotations for our Mr. Wilkes or Ramsey or Duke or Blue Devil and kind of put them at the right. So we have basketball, football, baseball. So actually to change that on the fly, we're going to basketball games now. Now it's just a basketball game. So what we want to do is now use Java 8 to make our repeatable annotations way more usable. So you can declare an annotation as repeatable by using another annotation. So it's going to go to CNAP place. And there's an annotation you can use here called repeatable. And then you want to specify the annotation that is going to be kind of our closing annotation. So we're going to do CNAP places that class. And now Java 8 will set up that entire infrastructure of doing this for us. So the benefit here, we're able to get rid of our CNAP places declaration and just use this much more readable format. That's one benefit. So we're going to do this in all of our mascots. I have 4. Mr. Worst. So this is him. We're going to go to Ramsey. And do the same thing here. Let's go to here. Right. So now we're using a repeatable annotation on all of our mascots. So that changes a few things. Also in Java 8 is the ability to get all the annotations in one call. So no longer do I have to get annotations and loop over the annotation type and loop through the annotations in that array. I can simply have a single for loop to loop through annotations. So let's do this. Mascot. Since our annotation is mascot, I'm going to do class. And we have a new function here called get annotations by type. And I can just specify CNAP place dot class. And now I have an array of CNAP plates object in my array. I can modify for loop object is another one. Get rid of this altogether. We don't need to check the type anymore because we have a type today. Scratch. and we want to do pin small spaces. And then this and holder, see that, set text, see my string got to string. And that's it. So hopefully when I deploy this, nothing changes. And we had the benefit of window readable code view holder.
You make this as a collection instead of an array.
Maybe. So nothing changes. We have repeatable annotations. So I can go in and still modify these. Our eagle doesn't show up at baseball games currently. And that should be reflected in our. So you mentioned instead of using arrays, use collections. That's a good question. Let's find out. So we go and not baseball games anymore. So let's do C-Dot places. Maybe you cannot use collections as an annotation number. That's repeating applications, and that's something else in Java. So you may have noticed we have all these mascots are pointing at somebody, except our eagle here. So now we want to filter the eagle out to see it's not pointing at anybody. So we're going to make masks. And in Java 8, you can, normally if I were to add one, you cannot add an implemented method to an interface for Java 8. Now you can. And they're called default methods. And the big one here is being able to define a default method and not have to implement that method in all implementing classes. So normally if I wanted to add a method called isPointing, it would go something like this. Now if I go to compile, I'll see all types of errors because Mr. Wolf, Eagle, Blue Devil, they don't implement isPointing. But now I can specify this as a default method by using default keyword and actually implement this. And then ideally, all my mascots will be pointing, so I'm going to return true here. Now this will compile, and whenever I call isPointing from a mascot, it will return true. However, as I said, the eagle is not pointing, and so you can override the default method in an implementing class by using the normal override method annotation. And so if I jump to the eagle, I can actually override it's pointing, and I can return false. So now this implementation of mascot will return false if I were to call this pointing point. So now the next question is, Java class, in Java, a class can inherit or implement multiple interfaces. So what happens if I have two or more interfaces that specify either the same name default method, or maybe one interface has it as, I'm abstract and one that has it as implemented. So we're going to do the case where we have two interfaces, both with the same name for the default class, or for the default method. And let's do this. So we're going to do, I'm going to create an interface called person. And this has a, and we notice that our eagle is not pointing. So that great candidate to implement our non-pointing person class. So we can jump back to eagle. And this does not compile. Actually, so you can do two things here, actually. So you can return your own value, or you can call the default method of the superclass. So in this case, I can do non-pointing person dot super dot is pointing. That works. I can do mascot dot super, and that works. So I could just return false or true. If I got rid of this, follow through an error that I inherit one of the defaults for is pointing from these two interface types. So that's the case where you have two interfaces with the same default method. Any questions so far? Yeah.
Have you found that you like default methods more or better than just the old way of an abstract class with default?
I kind of like default methods because abstract class limits you in that you're only able to extend one abstract class at a time. No, I've never used default methods on Android because it's super brand new, but in the past, I kind of prefer the interface approach versus the abstract class approach.
And do you try to keep the implementation, or you only use it for like simple things? You don't try to do a whole lot of logic there.
Yeah, so I've only used it to if I had, and it's mostly when I added a method after the fact, after I defined the interface, and it was a library, and I didn't want to have to update a library and break everything else down the line. I would kind of make a real simple function to return. In this case, that's an attribute that's going to be the same for most cases, versus like throwing a ton of complex logic in there. But it does, I can see why they made interfaces prevent you from implementing actual logic, because it can be kind of messy and kind of muddies the water just a tad bit. But they're continuing as you see here. So, yeah.
Can your default method implementations use any of the other interface requirements that aren't defaults? Like you could call them because you know the concrete implementation is going to be there.
Let's find out. So here I would call
return is animal.
Yeah.
Right. So like with that, think of like the collection interface. You could have you can implement functions where the implemented class only has to do the basic things that a collection needs, but then you could add things like map and filter and stuff on top of them, and they wouldn't have to be like array specific or anything.
That's exactly what the Streams API does. They add, and we'll see soon, they added kind of the streams method to all the top level interfaces for collection types. So that's actually a perfect use for that. And so the other thing you can do as well is define static methods here. And it's super simple static string, I'm going to get some data. You can return some data. And you can call it just like any other static method. mascot that gets some data and it works. So this is be perfect for like if you have like a class that just holds utility methods for this interface. Now theoretically all this can go in the interface and you have one less source file to mess with. So one last thing is we're going to go over our streams. And streams are pretty cool because they allow you to do some cool transformation out a whole lot of code. And so in my create, this is a recycler view that has 4 mascots in it. I insert these mascots into an adapter here. And it just shows all my mascots in my static mascots list. So what if I only wanted to show mascots that are pointing at people? Normally you have to iterate over the mascots, stick the mascots who are pointing to another array, and add that to the adapter. However, I can do that all in line here. And so this is the default method for mascots. So let's just jump into code here and see that stream is the default method. Now this is an implementation because it's only a stub, so it's not going to for a one-time exception. But this is how Java adds streams to our collection types in Java 8. So now I have the stream. I want to do, so stream has a ton of operators. And so we can get the first thing, you can get the last thing, you can do map and reduce functions, you can do a ton of stuff. I just want to get mascots that are pointing at people. So I have to do filter. Lambdas are pretty cool here as well. So I can do mascot. Mascot is pointing. And now, well, this I just want to add this to a list, so I can collect the mascots that are pointing, and in those 3 lines, I have now filtered my list of mascots to mascots that are pointing. And I just figured it was barking at me because this can be a method reference, so I can make this even cleaner. And now we can use mascot as pointing. Now when I move on to my app, I think the eagle won't be here because he's not pointing and has been set as such. So let's make sure that's still the case. Yeah. So normally when building Android apps, I wouldn't have to sit here and wait because InstaRun would be working. So is InstaRun still working for Android Studio for Jack?
That's still good.
Oh, still good?
Jack?
Yeah.
I think it worked.
Okay.
I can't be honest, sure.
Should know InstaRun because I've set here for a while. Any questions so far? We're still running. All right, so whenever Greta can come to life, what you'll see is the eagle will not be here. So that actually wraps up the coding aspect. I'll upload this to GitHub and tag it so you'll be able to step between the non-Java 8-ish 8i version of the app and the Java 8i version of the app. And now we're going to go through some caveats, and hopefully when I come back, I'll have something different. All right, just back. So now there are like some significant caveats of using Java 8 in your Android apps. So all the cool Java 8 features are not backwards compatible. So of all the things I went through today, the top 4 require Android N. So you're not going to be putting these in any apps that run on Marshmallow or below. Yes.
So you just have to compile with the NSDK, right? You can still run on old devices according to compile.
You can't. It will crash. As a matter of fact, let's set the to a lower version. All right, first restarts is C. Let's restart. All right. So now I'll set the MinSDK version to 19. So while that's actually still working, so when Google went with OpenJDK and Android N, that brought all the new APIs into Android N. Unfortunately, older versions of Android are still based on the older version of the JDK based on Apache Harmony. So those APIs aren't actually on that particular platform.
Okay, so it's not because once you compile it on the SDK, it's just bytecode, right? Or are there libraries that are in OpenJDK on the device?
It's just bytecode, but the virtual machine might not be able to process bytecode from Java 8. So, for example, for streams might not be interpretable on older devices. All right, so now we got here. Now let's try again. Especially when you see let's just do the first course. And now everything is locked up. So I'll jump back to that. But yeah, so today, the top 4 are only available in Android N. You could already use lambdas and method references in Java apps, and Android apps today on Android 4.4 and above. So that's not any news. And then finally, the final caveat is to build Java 8 apps on Android, you must use Jack. And Jack comes with a whole associated list of caveats. More importantly, if you use libraries for code generation, like your butter knife, your dagger, auto value, we'll use annotations to write some code for us. Jack supports it, but it's not visible. It's not visible to your project through Gradle. So all that stuff will break. So while you actually end up writing better Java 8 code, you'll have to go back and write all that boilerplate code that butter knife and dagger and all that helped you with before. So that's another caveat. And if we ever come back. So if you want to see this, I guess, just hit me up because I think Android Studio is having problems right now. All right, let me refresh. There we go. So and still, yep. So now we have our 4 errors. So to answer your question, if you use some APIs in older versions of Android, you actually get compiler warnings. So for example, let's make this bigger. All right, so we have this entire stack trace. Where is the site? Here we go. So we have an error. If you can see it, default method Boolean is pointing is not supported on Android API level less than 24. And so those are the kind of problems you'll run into if you attempt to use any of the new APIs in Java 8 on older versions of Android.
So does that mean you essentially have to wait until you're okay with your app only running on and
pretty much, yeah, pretty much. So that's like the super unfortunate part. This is going to take a while for like Android N to be really out there. So like maybe a year and a half, 2 years, you'll be able to safely use Java 8 things in your app. But until then, it's kind of like you're forcing yourself into like the sliver of the pie. That's basically all Nexus users for the first like couple months, and then everybody else.
It's a good sliver.
Yeah, it is.
It's a good sliver.
All right. So that's all I had. Are there any more questions? So you can get to this slide deck using the link here. I'll actually post this. I think we have a Google Google Spaces space for I/O, if anybody uses that. So I'll post that link there as well. And then all the links about Jack and Jill and kind of the downsides in more detail. And then, of course, more about Jack just from Google themselves, and then APIs in Java 8 and tutorials on how to use them. And that's all I had today. If there aren't any more questions, I guess we should probably go enjoy lunch and the live stream.
Can I go back to the previous?
Sorry?
Can we go back to the previous screen?
Yeah. Oh, yeah, right.